Good evening, everyone. Uh, our today's topic, we have taken like few of the interview questions from one of the top four companies, like Ernest and Young. So today I'm going to discuss about the interview question asked in those companies, and I have taken mostly the Python questions. So, our first question is, what is the difference between the return and yield in Python? So, first I'm going to explain about the simple definition, then later I'll explain you through the codes. So, what returns do? Returns ends the function immediately and send one final value, like or list or tuple, etc., and back to the caller. While when we compare to the yield, what it does, it turns a function into generator. It pushes after each yield, sending value one by one on demand without ending the function right away. To understand this more clearly, when we use yield, we use yield when we have large data set, and like we have to get that data set one by one, not all at a time. So we use yield like large data set or streaming, etc., and it does not store all value in a memory at once. It produces result as needed and can be iterated over loop efficiently. Okay. So if I have to compare between return and yield, so return is a regular function, yield is a generator function. In execution, if I check, like return runs once and then exit. What yields do? Yield pause and resume, and it give output on demand. Like, then what about the memory if we compare? So when we store the memory, store in memory, it lists store all the values like at a time, but it generates results slowly in case of yield. Okay. The output for return can be list, integer, etc. For output for yield will be the generator, and can iterate, we can iterate it. I'll show you with example in code for this. The result will be simple result in case of yield, in case of return, but in case of yield we have like streaming data, large loop, etc. Okay, then in like now I'll explain you through codes. So like what is here, as you can see that this is, I have defined one function which is for with return. Its name is with return, normal Python function it is. So when we run this and see the output, I have run this function. Okay, you can see here. Okay, so here I have run this function. What it is doing, like if we see the output, like sorry, so what it does here, I have used range. Okay, range function. What range can do? Range, when I'm writing this range equal to 3, range bracket 3, the what it gives output as 0 1 2. It will exclude the last number. Okay. And for I into I means it is squaring the number for I in range. Okay. Then here I into I means it is squaring. So what output we will get? It will do like for I 0, 0 into 0, 0, 0 into 1, 1. Sorry, 1 into 1, 1. 2 into 2, I into I, 2 into 2, it will give 4. So we will get this output. Okay, so this is for simple return function. It will give output at a time only as a list. Okay, square bracket, you can see it is a list. Okay, so but in case of yield, what it does, again I am defining a function with yield, and I'll run this function for I in range 3, yield I into I, same square I'll do for this function also. So again I'll run this, and now I print the output. It now every this function output is stored in this generator function. Now calling, now as you can see here, like I'll call this function using the generator object. I'll put this function is gen, and now I'll call this. Now I will print the value, so it will give one by one value, not at single time. Like for example, so sorry, first I'll run this. Okay, so when I print the value of this generator object, it will give one at a time. You can see here, like it will give 0 value first, then it will give 1 value, then it will give 4. First it gives 0 into 0, 0, then 1 into 1, 1, then 2 into 2, 4. Okay, so like this generator and yield function will work. So we can put this value in list. We can do it like this, converting generator to list at once. So 0 1 4, we will get the output like this. So this is all about list and yield function. Sorry, return and yield function. So return gives all result immediately and end the function. Yield, what yield will do? Yield gives result one by one and pause after each value. So yield is memory efficient in comparison to return. Okay. So now the second one is Python list and NumPy array. So in that, what is the next question is, what is the difference between Python list and NumPy array? So Python list is a built-in general purpose heterogeneous data structure in Python used to store an ordered collection of items. Heterogeneous means you can say that it contain different data types. Like generally what happen, like list contain uh, like int, float, string, etc. So it is a heterogeneous type of data. Ordered collection of item means we can access the data inside that list through index. So it is ordered collection. Got it? Now, NumPy array. What is NumPy array? NumPy array is a homogeneous. Homogeneous means all the data present in that will be in same data type. In as we see in case of list, we have different heterogeneous data type are there. But in case of NumPy array, we have multi-dimensional. We have homogeneous data type. all data either in float, all data either in int, like that. It is multi-dimensional. Multi-dimensional, like it is means more than one dimension. Like it can be 2D matrix, 3D tensor, it can be anything. Okay, like not for a single dimension only. Fixed type, that is data type is fixed. Like if the data is float, then every data is float only. Why it is like this? Because it helps to speed up and speed up the process, calculation process. Okay, so array from NumPy array is a homogeneous multidimensional fixed type array from the NumPy library, optimized for numerical and vectorized computation. Okay, numerical and vectorized calculation means numerical calculation like mathematical operations like mean, multiplication, addition, standard deviation, etc. Okay, and vectorized computation means like the operation, performing an operation on entire array at once, like without writing explicit loop key. For example, if I have array as a, and if I do multiplication of 2 on it, so it will automatically multiply with all the values of that array. But this doesn't happen in case of the list. So it is vectorized computation. Why we are doing this? Because it is faster and cleaner. Okay, so if I have to compare in in the Python list and NumPy array, like as I explained, Python is a built-in Python sequence that can Python sorry list is a built-in Python sequence that can hold element of different data type. NumPy array is an object that store element of the same data type in contiguous memory. Okay, data type are heterogeneous in case of list, homogeneous in case of NumPy array. If we compare for speed, Python list is a little bit slower for numerical operation. NumPy array is much faster. Okay, memory usage is higher in comparison in case of list because it store references to objects. Okay, NumPy array is memory usage is lower. Mathematical operation requires loop or list comprehension in list. NumPy array support direct vectorize operation. As I explained, a plus b directly it will add. A into 2, it will directly multiply all the values. Now, for dimensionality, 1D only in case of list. List, okay. But in case of NumPy array, it supports multi-dimensional. Okay, functionality, general purpose container. It is for its functionality is like it is used for general purpose container. For NumPy array designed for specifically for numerical computing, supports linear algebra, statistics, etc. Okay. Now, now I'm going to explain you with the code also. So here first I'm importing the library. Okay. So like NumPy library, numerical Python. Now here I'm creating a NumPy array for integer from 0 to around 10 billion integer. It will create a array of around 10 billion. Okay, 10 million. A range, what it do? It will create a NumPy array. So a contain an array. So a becomes now array. Okay. So if I have to perform any calculation in array, so it will be like, I have to run this. So now array is created. Now if I have to do calculation, I have to do this. I have performed this operation in array A and stored it in B. So now we will see the output. So it will, this code, it will show the output of initial 5 values of this A. So first 5 elements are like 0, 1, 2, 3, 4. And if we see the output, if we see the value of B, so it will be like 0, 1, 2, 4, 6, because it multiplied with A's every value. So every value get multiplied with 2. Okay. So this is the function of array. Now if we see list, so we are creating a list. We have 10 billion values in this range, which is inside this list. By using this list function, we will create a list which is stored in lst. and when and I have created another lst2, and in that I'm just taking a values from this lst x into 2 for x in list. So here I have to run a loop for it. Like this x, what it will, it again, it will go here, it take value 0 value, then it will multiply with 2 and will save in this one list. Again, uh, again it will go and take 1 from here, do multiply with 2 and save it in list, like that. Okay. So one, it will create, it is a slower process in in compared to numpy array. It will multiply at a time only with each and every value of that array, but in case of list it will go one by one. There will be loop, and then it will uh, create another list which will have value of this. Okay. So if I run this, now if I have to see the value, it will show the this value, original value, like 0, 1, 2, 3, 4 list value. And now if I have to run this, it will show the 5 element of list to lst2, which will be list into 2. Okay. 0, 1, 2, 4, both are doing same function, but that is much faster in comparison to. So here we can see that NumPy array store homogeneous numeric data in contiguous memory block. Okay. Operation are implemented in C loop. What is C loop? Like it is in vectorized form. Like at a time, which each and every value, row, column, it will multiply it. Okay. Then Python list store reference to individual, like Python list store reference to individual Python object, which causes the causing overhead. And NumPy avoid Python loop entirely and faster and more memory efficient. So Python list is slower and flexible, can hold mixed data, but NumPy array is faster, fixed type, and support vectorized math. Now, the next question is like, next question I'm going to explain about what is the difference between MAP function, apply function, and apply map MAP function. So like map function, it is a built-in Python function. What it does, it applies a given function to each item in an iterable, like list, tuple, etc. Okay, and it used for pure Python list or any iterables. Okay, now what does apply function do? Apply is a pandas method for series or data frame. Okay, applies apply function applies a function along axis per column or row. How? Because in data frame we have a 2D structure, no? So it will apply function in rows or in column, okay, or element wise for series also. Okay, so it is used for panda series for one dimension and 2D also, and so it is flexible and powerful in comparison to map. Now the third function we have is apply map function. What it does, it is pandas data frame method. What it applies a function to every individual cell, okay, in a data frame. Like it apply function cell by cell on, okay, so use only for data frame, not for series. Got it? So if I have to compare, like between map apply and apply map, so map belongs to built-in Python, apply belongs to panda series and data frame also, but apply map work only for data frame. Okay, map function works on iterables, apply function works on 1D or data frame 2D also, but apply map will work on 2D only. Okay, if we see operation level, map will work on element wise on iterable, but for apply function it will be row wise, column wise, flexible. But in case of apply map function, it is element wise, every cell. Okay, now for what is the output of map function, it will return the list or same iterable. If it is list, then it will return list. If it is tuple, then it will return tuple. Like that map function will work. Apply function also, if it is series, so it will give output as a series only, and if it is data frame, so it will give output as a data frame. Apply map function, what it will do, it will give output as a data frame only. Okay, so I'll explain all these in through codes. So now here again I'm importing pandas as PD. Now I have created a list NUMS numbers. Now again I'll create a list result map. List function will create inside value into list. Map function, what map function do? So map function applies the lambda function to each element of the number. Okay, it will make lambda lambda function to work for each of the element. This is only the work of map function. What lambda will do? So lambda will double each value. Okay, so what is lambda? So lambda is a way to create a small function, anonymous function you can say, without any name in Python. Okay, so here we have we have like lambda function. What it do, it will go like map function will make lambda function to run, like it will go to nums this list, take one value, then it will multiply by 2 and save it in like list. Then again then again it will go to 2 nums list, then it will multiply by 2 and will save. Similarly for 3 also. So as we see here, when I run this and I'll print the result, you can see that, see, it will give a list with output of this 246. Okay. Now if we see series using like second one, apply function, using series apply function. So what apply will do, as we know, apply is used for column and row 2D data. Minimum it requires 2D data, or series is also good. So first we created a series. This series function will create a series, pd dot series, and then I'll store this s underscore result. It will apply. Apply will apply on the lambda function which make it work on this series data. Okay, similar to ever. Okay, lambda function element wise it will perform the operation. So if we see the result, this is our result. Here it gives like list. It is here it is giving a series like 0, 1, 2. This is index and 10, 20, 30, because it is multiplying by 10 with each and every value of this series. Similarly, by through apply map function, we will see the data frame, how it works for data frame. First we will create a data frame. Here df is equal to pd dot data frame. This is a function for data frame. Then what we will do, we will do apply map function. Similarly, we make this lambda function to work for this data frame. So what it do, it will add for each and every cell. We have 4 cell here, 1, 2, 3, 4. We have 4 cell. It will add 0.5 to each cell. It will work element wise. As I explained, apply map, it will work element wise. Okay. So if I run this and see the result of it, you can see here. Okay, so if I have to see df value, okay, so previously it was like 1, 2, 3, 4. Okay, 4 cells we have. After performing this operation, we will get value like 1.5, 2.5, 3.5, 4.5, like that. It will work in each and every cell. Okay, so this is how each and every map apply map function works. Now I'm going to explain through code. I'm going to demonstrate how to fill a missing value by NaN. Missing value NaN in a data frame using the median value of each category. Okay. So I'll import the library for it here. Now I'm creating a sample data frame with a missing value. So I have created this data frame which having the column like category column A category, B category, and value inside it. A1 A np dot nan, this is 0, suppose you can say. A3 B10 B np dot nan B20. Like I have created this sample data frame. Then after that data frame is created, if I have to see what will I'll put like check. See, here is a category. Here you can see it in console, and then here is the value. Now, what I'll do, I'll compute median by category. So by MED means median data frame, I group by category, like A category 1, B category 1. And what it will do, it will find the median of the values, these value. Like A value, 3 value are there, 3 plus 1, and then divide by 3. Okay. Sorry, okay, sorry, midpoint. Yeah, sorry, yeah. So I'll find the median of the per category, like A value, and then B value, like 10, 20, and then I'll find the median for the B values. Okay, so what will be the median for it? I'll add like 20 plus 10 and divide by 2. Okay, so like that it will find the median. Okay, then see, sorry. So I'll store the value in MED, and then our median values are for A category I have 2, and for B category I have like 15 as a median value. Now what this line of code will do, it will create like value underscore imputed, this new table, new column will be created, and then the value dot what it will do, it will fill the value in value column wherever we have fill dot na value. Where we have na value, it will fill with the median value which we have in this med. Okay, so like if I run this code, and now it will print. So you can see here in category we have value, we have which we have in previous, and it created new column with values 1 2 3. It na value is filled by median values. So like that we can do. Okay, and next question which I'm going to explain you about, create a program which checks if any permutation. Okay, just give me 2 minutes. Okay, so create a program which checks if any permutation of a string is a palindrome or not. So at first, what is palindrome? Palindrome reads the same forward and backward. For example, MADAM, Madam. So from forward MADAM, from backward also MADAM. So just this is the example of palindrome. So how to find a particular string is palindrome or not? For that, there is a condition. We have to find even length word and odd length word. So for that, all character appear even number of times, even number, like for even length word, and for odd length word only one character may appear in an odd number of time, like middle letter we will take, then only it will be a palindrome, otherwise it will not. For that, I have imported a dictionary subclass counter. What it will do, it will count the, like, each character in a string. Okay, number of occurrence, frequency of each character, it will count. Then I have this function, I'll run this function. What this function will do, like, what I have done here, I have created one, I have defined one function, can, PRM, like permutation, PAL is palindrome. If S in the in string, if S in the string, then it will return as a boolean. Like, takes a string S and return a boolean object. Here you can see that. And then it will count how many strings are there, like how many values in that string are there. Then it will find the out count. Okay, like, and it will count the value from here. So for each frequency value, it checks if it is odd or not. For example, if we take for car race, so what it does here, you can see like that. For example, we have 2C in this car. See here, see palindrome. Okay, so if otherwise it is not a palindrome. So when I check for this, it will it will come up true because it is palindrome, because we have odd count car race. From here opposite, if we read like race car, okay, it is true. If we check for ABC, so it is not palindrome because the odd count is not there. So this is all for today. Thank you so much. Please like, share, subscribe, and please join 360 Digit MG for more such questions. Thank you so much.